Okay, while we're collecting the homework, let me just do this one. I'm going to do this fast, and if I lose you, you can watch the video. I don't want to spend a lot of time on it, but I think there was something in your homework about doing this, and the technique here would be to first split it up into two fractions. So thinking about when you add fractions, you have a common denominator. So it's kind of like pulling them apart now with the common denominator. So you have 3x over x squared plus 16. Plus, 7 over x squared plus 16, right? So this is based on adding fractions. Now we're just separating them, right? So then we need to come to each one of these individually. This one, what do you have? 3x over x squared plus 16. So this, undoing the chain rule that we talked about last time, this is always the first question you ask. It's the most common thing that shows up, is undoing the chain rule. So you always ask that first. Is this undoing the chain rule? Does it fit the mold? So I have basically 3x times x squared plus 16 to the negative 1. So what is the requirement for undoing the chain rule? Yeah. What is the requirement? Does it fit the mold? We got to answer that first before we jump into doing anything. We got to say, is it ready for undoing the chain rule? And the reason it is because, okay, try number 2.
Because 3x is the power.
It's exactly the right amount less, right? So it's 1 degree less than that, right? So the derivative of this inside is essentially what we have out here. And we can take care of a 3 versus a 2 factor, but x squared, its derivative is something to the first. And that's what we have. So yes, undoing the chain rule. So we look at that, and our attempt is x squared plus 16 to the minus 1 is what we focus on. And we do the antiderivative of the outside, right? Which is natural log. Okay, and then I have a 3. I'm also going to need a 1/2. Imagining if I took the derivative of this, would I get exactly this? No, I'd have a 2x, right? I'd have 2x, not just 1x. So the 3 just comes along for the ride. If I took the derivative, I'd have 2x. I don't have 2x. I need a 1/2. Okay, so that's that one. And what about this one? So this, I'm just going to do this fast, and you can meditate on it later. But you have to see this is not undoing the chain rule. We can't undo the chain rule here because we don't have an x to the power 1 in the numerator. So you have to recognize this is almost like just a basic rule that we know. Does anyone know? Something over x squared plus 1 is one that we know. What is that? Time to brush up on our mastery rules. Arctangent, right? The derivative of arctangent, or tangent inverse, is 1 over 1 plus x squared. That's derivative, right? That's derivative. Okay, so we look at that, we say, oh, it's almost like that. What's the problem? 7 is not the problem. What's the problem? The 16. So if I can get that 16 to be a 1, then I would have this situation. And I could do, the antiderivative would be arctan. So what do I do to do that? I can multiply the top and the bottom by 1/16. And then I'll have, now that's the antiderivative already. I still got some work to do here on this. So what would that be? That would be 7 over 16. So over here, I didn't want to spend time on this. There we go. Okay, so over here, we'll do this over here. So this is 7 over 16 over, this would be x squared over 16, or x over 4, quantity squared, plus 1. So I divided top and bottom by 16, and I got this. 7 over 16, and then x squared over 16, which is x over 4 squared, and then I got the one that I wanted. Now I can do arctan. Arctan of what? Arctan of x over 4. We also have the 7/16. Now, again, imagine taking the derivative. If I took the derivative of this, would I have exactly that? Chain rule, right? Chain rule. If I do the derivative on this and do the chain rule, I'm also going to have a 1/4, right? A 1/4 when I take the derivative of the inside. A 1/4 that I don't have. So what do I need? 4. Do you follow that? The chance for a question if... So to get rid of the 1, I divided by 16. That gave me this. I see that that's 7/16 of arctan, but now it's undoing the chain rule because it's not x squared, but x over 4 squared. When I would take the derivative of this, I would have another factor of 1/4 that I don't have here, so I need times 4 in my attempt. Questions? Yeah, please.
So how did we get the 4 or the coefficient for at arctan?
7/16 just came for the ride, right? Imagine taking the derivative of arctan of x over 4. You'd have 1 over x over 4 squared plus 1. But by the chain rule times what? By the chain rule times what? 1/4.
Oh, yeah.
The 1/4 that I don't have here. So I need a 4 to get rid of that 1/4 if I were to take the derivative. Is it better? Okay, let's move on to the next. So, like I said, undoing the chain rule is always, when you get a more complicated rate function, it's always the first question you ask. It shows up the most. As we learn other techniques, it'll show up within those techniques. So it's always the first question you ask. Is it undoing the chain rule? Is it undoing the chain rule? So let's talk about something new here. Undoing the product rule. Undoing the product rule. So remember what the product rule says. That if you take the derivative of a product of functions, it's not the product of the derivatives, right? It's not f prime times g prime. It's the first times the derivative of the second plus the second times the derivative of the first. So then this statement is true, right? So I'm basically doing antiderivative of everything, right? So if that first, the product rule is correct, then this is correct. If I kind of go backwards, then f times g is going to be what? The antiderivative of f g prime plus the antiderivative of g f prime. Is that fair? Okay, so here's the thing about undoing the product rule. Undoing the product rule isn't for problems that rate functions that look like this. Okay? That would be kind of like way too rigged. Like you'd hardly ever see that. Right? So what is undoing the product rule about? Undoing the product rule is that you are given one of those, right? So here's the given integral that we want find the antiderivative of, or the closed form accumulation function, right? We're finding closed form accumulation functions. So that's the given integral. But it's not, like undoing the chain rule doesn't work. Undoing the chain rule doesn't work, but we have the product of functions. So this is often a sign that you might use this technique, this new technique. The other one from the product rule is, this is something that we know how to do. So we can attain that one. We can get that closed form accumulation function. So if that's the case, then how can we find this then? If we know how to find this, How can we find the one I've highlighted in reddish? If we know how to find that one.
The derivative of g times the antiderivative of f.
Okay, so I'm just looking at this as, like globally, right? Globally, if I'm trying to find the value of this, what can I do? I can get that. I can't get this, but I want to be able to solve for this. This goes back to like pre-algebra. What would you do? Anybody see it? I can't get this, but I know this, and I might be able to figure out this. Yeah.
You just use that and then find the other one?
How? That's what I'm asking.
Oh, sorry. Well, if you know the derivative of f, then you could just take the integral of that separately, right? Then you could
Subtract it over. Subtract it over. That's all I'm looking for. Subtract it over. Subtract it over. You want to know this, you can find this, so you subtract it over, and you got it. Do you see?
Oh, okay.
You see? Yeah. So this is the strategy then. We're gonna think of that, whatever our given integral is that we can't solve, we're gonna think of that as one of the results of the product rule. That rate function is one of the results of the product rule, one of the two sum terms. And we're gonna determine what f and g are. And then we're gonna compute fg, and then we're gonna compute that one, which we can do. And then we're gonna solve, we're really kind of solving this indirectly. It's gonna be that, what, minus that. It's gonna be that, f, whatever fg is, minus g f prime. Does that make sense? So that's the strategy here. That's what we're looking for. All right, so let's. So here's an example. Let's do integral of 4x cosine x dx. Okay, so before we start working on this, let's ask the question: is this undoing the chain rule? Is this can we use undoing the chain rule to do this? Okay, so what I want you to do is make one small change to this so that undoing the chain rule would apply. Can you think about that? Think about one small change to that rate function would make it applicable, would make undoing the chain rule applicable. So think about that. What one small change, and maybe let's take 10 seconds, tell the person next to you. What one small change to that would make it a candidate for undoing the chain rule? Okay. I'm gonna have to like assign pairs, like have you sit next to your buddy, because lots of people just ignore me when I say this. Okay, so how about Stephen in the back? What did you think? There's one small change to this that I can. Did you talk to somebody? Maybe the person that you talked to. All right, Jose, what about you? All right, Kyle, what do you think? All right, okay, all right. Well, at least you talked. All right, yeah, Brian. He wants to do this. Would it work? Now is it undoing the chain rule? You should be thinking yes. You should be thinking yes. Why? Because this interior function now, its derivative is essentially 4x. So that works. That works. But it's not the problem we have. Oh, do that. Oh, it's not a big deal. But it's not the problem we have. The problem we have is this. So we can't do undoing the chain rule. All right, so what we need to see is, we need to see what 4x cosine x as one of the terms of doing the product rule. That this is like f g prime. So then the question is, what is the f and what is the g prime, right? So there's two possibilities. This could be the f or this could be the g prime. Likewise, cosine x is the other. So when you're just starting out, you just kind of take a stab at it. Just take a shot, and then if things don't get simpler, like so, then we're going to find g f prime, and that has to be doable. That's the point. That whatever you pick for f and g prime, when you set up that integral, you have to be able to do it. It has to be easier. And if it is, then you're good. If it's not, then you try the other way. Just switch these, right? So let's just go with, we'll just say f is 4x. We'll just go with the same order here. F is 4x. All right. And g prime is cosine x. So what do we need to set up? So we're going to solve for this indirectly by solving for fg and this antiderivative, right? So we're going to find those two things to solve for this one indirectly. So that means we need f prime. What is f prime? 4. And we're going to need g. What does that mean? It means we have a little mini antiderivative problem here. So it's just, yep, sine x. Okay, and so then, if we were to set this up, we would have, what would this integral be? It would be, so I'm just going to call this one a for the answer, right? So this is just going to be a plus integral of g f prime. So g f prime would be sine x, we found as g. F prime is 4. Before we go any further, we ask, is this doable? So if this is doable, then we made the right choice to start, which was f and which was g prime. Is integral sine x times 4 doable? Very easy, right? Very easy. Okay, and so that's good. And then we need also over on this side, we need f times g. What's f times g? 4x. All right, so these are like the original two functions that we took the product rule on, right? Did the product rule and got our 4x cosine x plus sine x times 4 when we did the product rule. So now we're home free. What is, so a equals what? That minus that, right? So 4x sine x minus, so we can just do it now. So what is the antiderivative of 4 sine x? Negative 4 cosine x, right? And then we have, yep, again, what does this mean? All possible net accumulation functions, starting at any value of a, right? So rather than write minus f of a, we just write plus c. But that plus c is our minus f of a, right? So how can we check the answer? Take the derivative. If we were to take the derivative of that, we ought to get 4x cosine x. And we do. We'll take the time to do it. Yes, we can change this minus to plus. All right, any questions? Does it make sense? All right, so notice what happened. Why did this become easier? Right? So why did we get an easier one? We had 4x cosine x and we ended up with 4 sine x. What about that made it doable? Where this one wasn't. Yeah. So here, what was it about this that said we couldn't do it, whereas here it's easy? Yeah, right. The x is gone, right? So rather than having 4x times sine x, now we just have 4 times sine x. So what accomplished that? What accomplished getting just a 4 instead of a 4x. Yeah, taking the derivative of 4x, setting that 4x term to f, so that now we have some insight onto how to pick the f and the g prime. When you have like a monomial like this times maybe cosine x or e to the x or something like that, taking the derivative of this helps. It reduces the power. That's what made this doable, by reducing the power of that x. So that's why that worked, by setting f to be 4x. We got just 4, and that made it, that 4 sine x, doable, attainable. So that's one kind of, now we've gained some experience in how to pick which should be f, which should be g prime. Okay, questions on this one? All right, another one. Let's do antiderivative of e to the 3x times x squared. First question we ask, is it undoing the chain rule? Does undoing the chain rule work? You should be thinking no. What one small change could we make to this so that it would be undoing the chain rule? Everyone's talking to somebody. What one small change could you make to this rate function so that it would be undoing the chain rule? Go. Everyone talks to somebody. Okay, let's see. Chris, what did you guys think?
We said changing e to the 3x to e to the 3x cubed.
They said this. Make the e to the 3x cubed, and that would be undoing the chain rule now. Riddick likes it. Yes? That's it. That's it, right? Because we need, this is the interior function. We need its derivative as the other factor, right? So derivative 3x cubed is essentially, x squared is essentially the derivative of that. Again, product factors, we can, constant factors, we can take care of. So that would be it. But that's not the one we have, right? It's not what we have. I'm going to use erase instead of undo this time. There we go. Okay. So then we say, okay, it's not undoing the chain rule. We have a product of two terms. Maybe this is f. Maybe this is like fg prime. Maybe this is like fg prime. Okay? And we could go for undoing the product rule. So what are we going to say for f, and what are we going to say for g prime? So now we're going to try to make this like this one. We're going to think of this as one of the two terms that resulted from the product rule. Find the other term. Find the original function we took the product rule of, and subtract, right? So what should I assign to be my f, and what should I assign to be my g prime? F should be? Yeah, from what we saw in the last example, we should make it x squared because that derivative is going to lower the power. G prime is 3x. That means f prime is 2x. And g is? Okay, now actually this is like a mini undoing the chain rule, right? So antiderivative of e to the 3x. Good. 1/3 e to the 3x. Everyone with me? Okay, so now I'm going to rewrite it this way. So again, I'm going to call that A for answer, plus g f prime. G is? And f prime is 2x. And then this would be over here, f times g, which would be x squared 1/3 x squared e to the 3x. Okay, so the whole kind of question here is, did we make it easier? Is this something attainable, something we can do? I got 1/3 e to the 3x times 2x. So first question, is it undoing the chain rule? So maybe it's undoing the chain rule. We know how to do that. Is it undoing the chain rule? No, because we would need a square there, right? It'd be 3x squared. Yeah? Okay, because if I were to take the derivative, yeah, this is antiderivative going this way. Yeah, this g prime, this g. You good? Okay, cool. All right, so if this were 3x squared, then we would be good for undoing the chain rule, but it's not. It's 1/3 e to the 3x times 2x. So what's going on? How are we going to be able to do this? So it is kind of simpler, right? It is kind of simpler, but it's still not attainable, like with what we've learned so far. Or is it? Yeah. See that? We do. So we're going to do undoing we're going to isolate this as its own problem and use it again, undoing the product rule again. And so then we'll have like undoing the product rule inside of undoing the product rule. So that's what you're going to do while I take attendance. So you're just going to work on this problem. What I've put a cloud around in orange. Just think of that as its own problem of undoing the product rule. And then we're going to get an answer for that, and then we're going to come back to this one and get our capital A answer of the whole problem. Okay, so
I know we're supposed to do that, but this is what you're
okay, let's see what progress you made here. So I'm going to use to set apart this like interior problem where we're going to have to do it again within itself. I'm going to use capital F and G. That kind of helps to set it apart. So Lucas, how'd you do on this? What did you say F was?
I said F was 2x.
He wants 2x, therefore F prime is?
2.
And then G prime?
1/3 e to the 3x.
Okay, and G is?
1/9 e to the 3x.
How'd he do? That's right, yeah, we got thumbs up, yep. So now, this we're going to write as equal to then. This is going to equal what? Capital F times G, what? Minus integral of capital G F prime. Make sense? Right, so this is its own problem, so it's going to be that thing minus that, but with the capitals. Capital F and G. So I did F times G minus integral G F prime. And so we'll just plug everything in. 2x times 1/9 e to the 3x minus. It's supposed to be a 3. Kind of is. A little extra loop on it. Try that again. Here we go. Okay. And then minus antiderivative of 1/9 e to the 3x times 2. One last step. So we can write 2/9 x times e to the 3x minus, okay, so now we got antiderivative problem. We'll have 2/9. And then we have, again, antiderivative of e to the 3x is 1/3 e to the 3x. I'll stop there. So there's the sub-problem. There's the problem that's within the other problem. So that this antiderivative here is equal to 2/9 x e to the 3x minus 2/9 times 1/3 e to the 3x. Any questions on that? Did you get that or make some progress towards that? Yes, please, Brian.
Isn't there a plus C?
Okay, yeah, so there would be. So, and then we're going to have like a plus C for this, and then all those are going to add up to another, just one big plus C. So we can just tack that on at the end. But yes, if this was its own problem, this is what we were doing, we would need the plus C. But knowing that we're going to plug it in here and solve for this A, we'll just put the plus C at the very, very end. Yeah, but yes, you're right. So I'll just do. Yes, please.
So for the f of g minus the integral g of f prime, well, how come f of g doesn't have equal
Because it's the two original, it's this,
to? Oh.
right? It's the two, it's the original function that we took the product rule of. So there's no,
Yeah, that
Yeah.
makes sense.
uh-huh. Yeah, I'm just following this general pattern right there and rewriting it with our capitals. Other questions? Okay, so now we're ready to go. So answer A is what? A is equal to what? This minus that. So it's going to be 1/3 x squared e to the 3x minus what that is, this whole answer, right? So minus, make sure you get the parentheses if you're subtracting a sum of terms. That's 2/27. Now we got the plus C. So, yep, that's right. And so, yes, so now we can distribute the negative. The negative will distribute to both because we're subtracting the value of this, and that is this two terms. So I'll write it one more time. 1/3 x squared e to the 3x minus 2/9 x to the 3x plus 2/27 e to the 3x plus c. Did I lose you? So if we were to take the derivative of this, we ought to get exactly 3 to the x squared, right? Because this is the antiderivative. What, or the closed form? Net accumulation function, equivalent to this open form, net accumulation function, right? That's the whole point of this segment of the course. Given an open form net accumulation function, we want to find the closed form. That's the closed form, right? It generates the exact same values, but a lot more efficiently, right? It generates all the same function values as that like in GC, but a lot more efficiently. Questions? Yeah.
If we got one like that on the exam, would you want us to completely simplify and like reduce the fractions, or could we just like leave it?
It's not a huge deal to me. Yeah, so we want to get a closed form. If the closed form isn't fully simplified, it's not, always do obvious simplifications, but it's way less important than getting a closed form that's correct. But yeah, if there's obvious simplifications that make it tidier, always do those. But if simplifying it takes a lot of effort, then it's not worth it. Yeah. Okay, another one. We're doing time. Great. All right, let's look at this. Put it right there. Okay, first question we always ask is it undoing the chain rule? Or just something easy we can just write the answer down. Is it 1 over x? Is that it? So, scores of calculus students throughout the ages have written something like this. Why isn't it right? That's the derivative, right? That's the derivative, not the antiderivative. So we don't want to do that. That's not right. So, is it undoing the chain rule? That's the first question we always ask. No, we don't. It doesn't follow the form for undoing the chain rule. So, could it be undoing the product rule? And if so, how do we see this as f times g prime? If it's undoing the product rule, how do we see just ln of x by itself as the product of f and g prime? So this is kind of similar to the tricky one we had last time in class. How can you see ln of x as the product of two different things? Product of? Yeah.
Well, we can imagine G prime as 1.
Okay, so yeah, so we can see that as, we can look at this as 1 times ln of x. So then the question is, where's the 1 and the ln of x going to go? So should ln of x be f or g prime? And you're going to find out very quickly there's one way that's much better than the other. Should ln of x be f or g prime? So if it were g prime, look at what you'd have. What would you have to do? This is the problem that you're given, right? So this doesn't work. It doesn't help. It doesn't help because if you set ln of x equal to g prime, well, then you have to get g. Well, that's what you were asked to find. So this is not the way to go. Let's see if it works now. There we go. So that leaves us with f is ln of x, and g prime is 1. Fit? Okay, let's see if you've made some progress. Lauren, back here. What did you say f prime was? 1 over x. And what about g? X. How'd she do? Yep. Okay, so now we just plug everything in. F times g is x times ln of x. And g f prime? X times 1 over x. How are we going to handle that? X times 1 over x. Do the math. Green for green light. What's x times 1 over x? 1. So answer is x ln of x minus antiderivative of 1 dx. X. So how does this work that the derivative of this is ln of x? How is it that the derivative of this is ln of x? Let's just do this because we haven't checked one yet, so let's check this one. How is it that x ln of x minus x, its derivative is ln of x? Well, derivative of x times ln of x is first times derivative of the second plus derivative of the first times the second, right? ln of x, sorry. Minus derivative 1. So this is right. So this is 1. Minus 1 is 0, and you're left with ln of x. See that? Okay, any questions on that one? Okay, so when we did e to the 3x x squared, how many times did we have to do undoing the product rule? Twice, right? When we did 4x cosine of x, how many times do we have to do the product rule? Once. So then how many times are we going to have to do this? Watch this. How many times are we going to have to do it? Okay, I want you to start. Do it the first time. So do it the first time. Go.
Let's see.
Anybody discover anything? Emily, did you discover something? Yeah. Right, and so how many times do you have to do undoing the product rule? Only once, right? See this? Because it's ln of x, the derivative is 1 over x, ln of x goes away. And we only have to do it once. So we get minus antiderivative of 1/10 x to the 9th. What is that? X to the 10th and 1 over 100. Is that the happiest thing that's happened to you today? Okay, I think our next exam is a week from Friday, the Friday before spring break, I think. So we'll start talking about that Friday and definitely Monday. But we're going to start having web work again. So watch, and web work is due every class, not Wednesday. So Wednesdays is when written homework is due. So there may be web work due Friday on this stuff. So please check Blackboard and announcements.